Hello and welcome to another episode of Elektor Engineering Insights. I'm Tristam Williams. And today we've got a fantastic session lined up. We're taking a peek into the world of robotics, creativity, and embedded systems with, unfortunately, one guest, because we meant to have two, but Swap is a bit under the weather. But these guys have been making waves in the maker community. Whether you're an engineer, a hobbyist, or just love seeing what's possible when technology meets creativity, you're in for a great discussion. So joining me today is Alex, one of the minds behind every flavor of robot. Alex has a degree in mechanical engineering, impressively enough, and he has a focus on embedded systems and PCB design, while his partner Swap brings expertise in AI and software. And together they've created some incredible projects that blend engineering, robotics, and creative problem solving. We'll see some of those later. Alex, welcome. How's the East Coast?
Hi, thanks for having me, Brian. East Coast feeling a little bit warmer than it's been recently, but yeah, how is it where you are?
The aircon is on. We have I don't know what this is in Fahrenheit, but it's about 29 degrees Celsius here. So do the math. We've got a lot to talk about, but I just want to welcome our audience quickly. I see we've got Frank de Hart from Belgium. He's a regular. We've got Denmark in the house. We've got Hallo aus Oldenburg, I presume that's Germany. And we've got Norbert from Hungary. So for all you faithful listeners, let me tell you about today's giveaway. Put that up on screen. We have 3 Elektor Raspberry Pi Pico Advanced Kit bundles. It includes over 80 hands-on projects covering everything from basic electronics to RFID, sensors, motor control. So visit the giveaway page there, and I will give you the code word later if you know the deal here. Before we go on, I just want to also acknowledge our sponsor, MyBotShop and Quadrabit Robotics. They offer various robot technologies from simple grippers to mobile robot platforms. Bring up the banner there. Yes, I think that's looking good. Whether for research and development, inspection, maintenance, or exploration, their robot solutions can be used both autonomously and remotely. So they'll be happy to advise you on selecting the right technology and to offer comprehensive support for your individual requirements. So their URL is mybotshop.de, and if you're English, /en. Let me just put that up on the screen for now. Anyway, back to Alex. Alex, your channel has exploded over the last year. You started off relatively small, but I think I'm in an exclusive club because I stumbled onto you before you were so cool. So this video here from 8 months ago was the etch that I looked at, and you actually inspired me to go and buy an Etch-a-Sketch, which I haven't done much except draw. I don't have a 3D printer yet, and I'm not sure this is the application to warrant the expense, but how on earth did you come up with that idea?
Well, I will not claim the idea. I think a lot of people pointed out on the video, there's a lot of Etch-a-Sketches that people have made robots out of. We just wanted to do it as a test because we had just designed a new motor controller. And we were thinking like, oh, what's a really quick and easy application for this thing, which let us drive 2 brushless motors with like servo position control. And we had seen other people make kind of like stepper motor Etch-a-Sketches before. And we're like, why has no one put out like a really fast one on YouTube? Like, it seems like all the control engineers out there would love to do this. And we're kind of control engineers, so we would love to do it. And one thing led to another, and we tossed it together. Yeah, that video was for our 600 subscriber special, so it really did blow up.
Yeah, I mean, it's now on 724,000 views. I've got it muted at the moment, but we can take a look. That was quite a setup, quite a rig you had there. You've gotten a bit smaller lately. You've iterated the design
a bit. That one, whenever we made it, I was kind of like thinking of like, I really like need a way to make it not just another like servo Etch-a-Sketch, like aesthetically. And so we were trying to make it look like an old vintage Sony camera that we had seen that like folded out and then you could take a picture with it. And that part kind of got, I think people kind of missed a lot of that in the YouTube video. I should have like hit that harder, that like this is actually like a replica of a camera, but people just kind of saw the Etch-a-Sketch part and we're like, oh.
Well, that is the main attraction there. And you did that, and you had, what, 600 subscribers at the time? Was it always in your mind to grow this channel? Whether it surprised you at the rate of growth or not?
It definitely surprised me, the rate. Like, I did not expect that by, like, when that project started, I really felt like we were just kind of doing like weekly dev vlogs, and kind of like making YouTube has just been kind of like a passion, a hobby, one that we've been trying to take seriously. Like, I really enjoy it, but it was never something that I thought at that time would be like this gigantic thing. We really thought that the path was going to be, we built that project, we got into open source, and then we met up a bunch of YouTubers at open source, and that is what would like help us go. We didn't expect that the video to get into the thing was what would make it all blow up.
Yeah, and you were quite nervous at open source, as I could tell, trying to get your stuff up and running.
Oh, live demos, right? Like every engineer's like biggest fear.
And then I'll show you your updated video. That's where you spoke to Princess Etch. But you were doing a demo here, and in fact, you could do a demo for a week because you've got a video there. But hard to believe that it's not actually time lapse. That's the actual real-time speed. So I'll take over my screen here and put up your video. Could you give us a demonstration of that?
Yeah. I think let's start off with this demo. I'll drag this in here. All right, we can all see. And this is live time. So we just drag and drop a photo into our web interface that's hosted, and then the thing manages it and starts drawing by itself.
That's insane. Yes, if I saw this off the cuff, I would think that is time-lapse, so not that impressive, but you're actually doing this in real time.
Yeah, you can see the plants in the background being moved by like my fan that's blowing on the Etch-a-Sketch here. So no speed up here. But yeah, I mean, even in real life, it, like when we are watching it, it's still kind of like hard to like, it looks so weird. Like it just, Etch-a-Sketches aren't supposed to move that fast.
Yeah, exactly. And mine does not move that fast yet. But I tell you, I was surprised at the kids enjoying this, because it's a toy that I had around in the 80s, and they just want to play around. But I was young. I thought they could only draw straight lines. I had no idea how to do a curve on these things back in the day. I said to my mother, how do you draw a circle? And she said, practice. That was not helpful.
Yeah, I remember having one of these as a kid, and I watched my dad drew a quarter, like drew like all of the coin and the face on the coin, and I never figured out how to do that. I still can't by myself do that, but we can now build a robot that can.
Well, that is quite incredible. When you approach a project like this, how much is plan and how much is you learning as you go along? How much is play, you ask? Plan versus stuff comes up along the way and you just go with it.
It's definitely a healthy mix. I think it's like, as we've gotten better, especially like working as a team, because the guys on here on the YouTube channel with me, I mean, we've been working together since college, and definitely like you get a sense for what is like a high risk. You're like, okay, you know, I have like a 20% chance of getting this right, maybe the first try, versus then there's some things that you've done so many times. It's like, I know for a fact I can design that one first try, or I can try that and it's going to work. But I would say like there's definitely not a single aspect of the design or mechanism or software that wasn't at least a little bit unplanned. You know, nothing goes exactly to plan.
Yeah, I remember the luxury days of being a student and having a lot of time, and you could just go wake up one day, go down any dark alley, and if it's interesting, you can just stay, dig deeper and dig deeper. But nowadays we have deadlines and pressures, and so you have to hope for success and not just learning, I guess, but you are learning a lot. And are you inspired by teaching as well as learning?
Yeah, I mean, that's one of the best parts of doing all of this on YouTube is like, even when it's a little embarrassing to show the mess ups and the failures, it's really, it brings me a lot of like internal fulfillment to like know like, oh, we can share these like mess ups and share these things that we're learning. And even like there's always someone out there that like needs to like learn that lesson and can maybe avoid a little bit of pain or make their project a little bit better, or inspire them to do something. Um, and yeah, I love the teaching aspect of YouTube.
Yeah, that's awesome. I'm not sure I have the confidence to try and put something together live, but I mean, we had Patrick from Build Your CNC on recently, and he goes live every day trying to build
Wow.
stuff, and there's no guarantee that you're going to come right, but he doesn't care. He just fights through it, and it's actually interesting to the audience to see the potential dead ends, and of course they're there online, so they can say to him, "Hey, I think you missed the black wire," something like that.
They're always quick to point out the errors.
Yeah. Impressive, as we see on the screen now from Tarun. Oh my gosh. Yes, indeed. Oh my gosh. That thing is fast. Now, you would.
So I was just going to point out something on this demo coming up. All those other two demos that we drew with the Darth Vader helmet and the Salvador Dali, those are just like auto-generated from our code. Like we just drag those into our website, and the Raspberry Pi or whatever computer you want to use computes the G code to draw it. But you can also send it, like if I sit down in Adobe Illustrator or something and draw out like an SVG myself, you can also create some like really artistic looking things. And so this is like kind of like a hand-drawn demo that I don't think I put this in our video. So this is kind of just like a completely special one.
Okay, so this is hand-drawn.
Of the Bean
SVG
in Chicago.
Okay.
Have you ever been to the Bean?
No, but I've seen it. Quite an impressive
definitely like a
hunk of metal.
it's I never got it until I went, and I was like, wow, this is actually really, really pretty to like walk up to, and kind of like an art piece that you experience.
Yeah. And yeah, obviously, so for the audience who hasn't seen your videos, what Alex basically does is take a random image like of Darth Vader and put it into some software, and I shouldn't have interrupted that, sorry, but I wanted to show you GitHub. All the source code is there. There's a lot of Python files. And this was hand-drawn in what, Adobe Illustrator or?
Yeah, I used Adobe Illustrator, and I just kind of started doodling, and it's kind of fun when you're doing it this way because you get more control over, like, it's going to follow the SVG that you draw exactly in the same order that you draw it. And so, I mean, besides the jumps back and forth, like it's figuring that out on its own, so it doesn't like overwrite white space.
Yeah.
But yeah, when you're kind of drawing your own SVG to send to the Etch-a-Sketch, it's fun because I'm sitting there thinking like, this is where the cursor is going to go, like every line.
Yeah. And that's one thing that fascinated me as a kid, because computers didn't do physical things at all. Everything was on the screen, and to move things or turn actual lights on. If I had seen this, I would have been floored. In fact, if I saw this in real life, I'd probably still be floored.
You know, that's funny that you say that. Like that phrase is, Swapnil and I talk about that all the time, about like, how do we get people into robotics, and how did we get into robotics? And it really is like shortening the time to make something move, make something like happen in the real world, I think.
Yeah, exactly. For example, I have a lot of Raspberry Pis, and I try and impress the kids. But just booting up into a GUI or something, yeah, we've got Windows for that. It's not that impressive. You've got to show them the GPIOs and actually making a plastic dinosaur move or something. Then it's interesting. and from anywhere in the world. Yes, that bean is, Chicago bean is very impressive. I mean, so you're artistic, not just engineering.
I've always liked art. I think before like I really got into engineering, I didn't know that I was going to be like a STEM person when I went to college. And then it was at some point I realized that engineering was another tool set to make stuff. So I think it's kind of like a little underappreciated that art and engineering are heavily connected. Especially when you're going through school and you're doing all the math and stuff, it feels wildly disconnected.
Yeah, but when you come out of all of that, I can relate to wanting to make an engineering project that has some artistic meaning to it.
Yeah.
I can't think of some ideas right off the top of my head, but I've had some crazy ones. Like you could encode a JPEG image on a picket fence as you drive past it if you just use RS-232 protocol and different
Yeah,
blacks
that would be
and whites,
cool.
you know. So you'd use a lot of embedded systems. What's your go-to? I've seen a lot of ESP32, but you obviously mentioned Raspberry Pi. You like Arduino. What's your go-to
Yeah,
chip?
I am a huge fan of the ESP32. I think like I mainly came across it because of like the cost. I was like, wow, for the price point of having the Wi-Fi and Bluetooth embedded like with like these modules that I can just slap on top of projects. I was a big fan of that. And then my first job out of college, I was working in the ESP IDF, which is like their C++ environment from Espressif.
Yeah.
And that kind of got me even further roped in. So now I almost exclusively work with the ESP32 on the day-to-day. But I really like Arduinos. I really like the Raspberry Pi chips that they're coming out with. Those are kind of making me excited. And then, yeah, what else have I worked with? I've worked with PIC microcontrollers, or the PIC boards, but that one felt extremely low level. I felt I think I wrote like a couple of brushless motor control projects in them, and that's a little, I kind of like how all the new chips are coming out. You get higher level features, little like operating system-esque things, and
I
don't have to deal with registers so much.
I enjoyed working with the registers, actually. I did a couple of PIC projects, but back in those days, I had to bit bang the parallel ports on the PC in order to program the chip. And I had some successes, but the most recent project was to generate black and white composite video. Never worked. I still have the enclosure and the switch and the RCA connector, but nothing comes out of it. Of course, back in those days, I never even had an oscilloscope, so with a multimeter, you can't really debug much.
Yeah. Well, have you seen those little like USB like wait, I have one. What is it called? A serial. These things, the logic analyzers.
Yeah. I've got
these things are so cheap.
Yeah.
They blow my mind. Like so much better than an oscilloscope for the digital stuff.
Yeah, because you got a lot more channels. And you're just reminding me now, back those 20 years ago, we didn't have USB, or maybe 25 years because I'm getting older. But we did have a parallel port that would do standard TTL level signals, and you could programming in assembly to rip those signals in as fast as possible on multiple channels. And then what I would do is just fill up the memory and then write that out to disk and then analyze it. And it was actually helpful. But like you say, now you've got the USB solution, multiple channels, and so cheap as well. Things have gotten a lot easier. I was quite astounded by the Arduino IDE when it first came out, because I could already program in C, but I was used to embedded always being such a hassle. Special PIC programmers and development boards, and here's something you just plug in by a USB, you write your little big blink program, and there it's up and running.
Exactly. And they've done like I mean, just the versatility, like to be able to, you can still get down into like as far down the nitty gritty as you want to, but for beginners, whenever they're like learning, or like people that just are trying to focus on like some higher level function of a robot or a system, it's really nice to know that there's like simple things to fall back on, that kind of abstract it all away. I think it's amazing for education.
Yeah, absolutely. So you start at the top, and you can dig down as deep as you want. Now, I've got a few links of yours. I've got your YouTube, I've got your Discord, your Patreon, your Instagram, your GitHub. But this is the YouTube that seems to be a lot of activity here. Let's talk bigger picture for our audience who maybe has not checked out your channel. But I'm going to dump the link in the comments here so that if they haven't, please do visit Every Flavor of Robot on YouTube. Bigger picture, where is your biggest surface area in terms of reaching people? Is it YouTube? Well, obviously, after you've exploded from 600 subscribers to 50,000 in a year, but you were doing other stuff before that. Where are you making the most impact?
That is an interesting question. YouTube is definitely like where most people see us. I think it's the YouTube, and then like we like have like a Discord community that now has like 400 people in it, and a large portion of them are pretty active, which I feel like if people like enjoy our YouTube videos, then they want to get more involved in like actually building robotics. The community on our Discord is probably like the highest surface area. But then we have like a whole other side that this YouTube channel is actually like letting us explore. And that is through like all of our open source hardware that we're developing. So like I said, like this Etch-a-Sketch was a fun YouTube video, but it was actually just a test project for our motor controller. And I'm hoping that like where our most impact will be in the next like while will be through our like our motor controller that is actually working with Carnegie Mellon's robotics intro to robotics class.
All the way up
Yeah, I
there
don't
at
know.
Carnegie Mellon.
Yeah, they're
this
right
was
here
your-
in town next to us.
This was your demo, and I see you've put exploding flames on it.
Oh yeah.
You were really worried that's going to work. That was you at open source. Oh, and I
Yep.
see you've got an Insta360 camera. Is that the X3?
That was the X3, I think. And then now I have an X4 here too. I like these things.
Great. I've got an X3 as well. Is it worth upgrading to the X4?
To the X4, I think the battery life got a lot better. And the screen is a lot easier to work with. Yeah, you know, I would say I'm glad I upgraded.
Awesome.
Not
So for
sponsored
the
by them.
audience, when I go out like to Embedded World or Electronica, I like to take a 360 camera. It can shoot like what they've done here is shoot in all angles at the same time, and then you can later edit. I'm not sure if this is the Insta360 camera.
No,
But yeah.
this was our DSLR camera.
Okay. But with the 360, as some people have told me, you can watch the same video 8 times and reorient it and watch what somebody else was doing. So yeah, it's quite amazing, the technology we've got. And this is also real-time drawing. Okay, so speaking of Discord, I asked you on Discord about making this video, which is 28 minutes long. And I know that editing is a pain in the you-know-what. And you said this took months to edit, but surely not months, 8 hours a day.
Yeah, I mean, the art of video editing to me, it's like it's hard to say like how much time is even going into the video. It took months in the sense that like I would write together the story that I thought portrayed the events, and then I would watch it, I would edit it, and then I would watch it back, and I'd be like, well, that's just not going to work. It's either not going to do well on YouTube, or it doesn't convey the image that I had. Or a lot of the times with a video this long, I feel like your brain doesn't have enough space to even keep track of everything. And so I would like have an idea. I would edit halfway through the video. I'd be like, I don't know where this vision was going. I'm going to restart. And so you kind of do that a couple times until after a couple months, I got to a video. I'm like, okay, this one we can post on our channel.
Awesome. Well, it is an impressive video, but I want to cry when I think how much time it took you to put this together. You can't complain, though, with 155,000 views from 4 weeks ago. That's not too bad.
Right.
And as a content creator, I apologize to our electronics audience who wants it to be all technical all the time, but I just want to know, what do you edit on?
I edit on Premiere Pro.
Okay.
They got me
Me too.
hooked when I was a student in college on the Adobe suite, because I think the creative plan, when I was in college, the creative plan was like it was like $5 or $10 or something for all of the apps. And now I'm stuck. Like I like all their tools. Not going back.
Yeah, I use Premiere Pro too, but I think I'm scratching the surface in terms of my knowledge of it. So I'm probably doing a whole bunch of things the long way around, and the editing takes longer than it should. I need to take a Udemy course on Premiere Pro. But you are doing a lot of content creation, which is time consuming. And how does that affect your actual engineering creative time?
Oh, yeah, it is definitely an internal battle of like, how do we, because like a lot of channels have, you know, kind of nicer machines for their content, where it's like, oh, it's like their personality is the thing that everyone's there to see. And, you know, maybe people are here for my personality, but I think most people are probably following the robot channel for the robots. And it's like, how do you spend time to develop engineering and put out the content? Right now, it's kind of like a little bit of a week to week. Like I'll do a week of like just work, and I'll try to record as much as possible. And then I'll sit down and try to figure out, okay, which content is usable there. And then on the other side, we also plan out kind of pretty far in advance of like, these are kind of like these hero video ideas that we want to be working towards. And like whenever those milestones are hit, we like sit down, and I just basically stop being an engineer entirely, and I just work on the video. We're trying to transition and become like hand off some of the editing to either an external editor, or also our team. My teammate Jesse helps me edit and write these videos.
Yeah, that's probably a good idea. Very useful, because with video being linear, when you have 8 hours of footage, to find what's useful, you've got to sit through 8 hours of footage, and that can be really painful.
Yeah.
Unless you've scripted it in advance, and your 20-second shot, you shot for 20 seconds and you knew exactly what you're doing. But that doesn't happen when you're unboxing and exploring things, and you're running into mistakes and take 3, take 4.
Yeah. Well, I mean, sometimes you can like script out like the core concept. Like we got a little lucky on the last couple, the first Etch-a-Sketch video, where we were like scripting it out, and we're like, I have a feeling one of these things is going to go wrong. And so we kind of like were able to like account for like a catastrophic failure or something here and there, and then keep it rolling faster. But yeah, a lot of the times you write, it's like almost a waste of time to write a script for an engineering video, because halfway through you're like, we never would have foreseen that we'd have to go this direction, you know?
Yeah, exactly. That does make it difficult, and that's why I say I feel your pain.
Yeah, how do you manage you guys have like a tighter timeline on, you have more regular content than we do.
Yeah, absolutely. We try to keep it coming as often as possible, and you know, there's some challenges like first unboxing and then putting it back in the box, and then pretending to unbox for the first time because you didn't realize that wire was supposed to go in there, or yeah, and it is a rush. That's why I'm asking you. I'm picking your brain for some free advice. I'll have to buy you a coffee for that. Have you ever had a project? I mean, you came close at open source. Have you ever had a project completely fail and you had to learn from that?
Oh, on our YouTube journey, we've had a couple. one of them was we were like building a balance bot. And this was like before we started building these motor controllers. And it was actually kind of like what sparked our need to design them, is because we kept building these robots and realizing that we had the same 5 problems show up. We're like, we got to get a microcontroller, we got to get a power system, we got to connect sensors to it, and we got to add motor controls, and then we got to like connect to it over some interface, Wi-Fi or something. And we had set out this like really big content plan calendar, because that's what we read that people should do if they want to take social media seriously. And then that's when we ran into, we're like, oh, these robots don't get built fast enough, like at all. we're like super behind schedule. And there was one that we were trying to make a balance bot that could move its legs up and down on like a rack and pinion. So it'd be a jumping balance bot. But we had so many hardware problems that like it just like we could get it to balance and then it would just explode. And I think like just the amount of like resoldering and rebuilding of that robot really like spurred me. I was like, we're canceling this project entirely. We're going back to square one, and I'm going to learn how to do like PCB design for this project so that we can actually like move forward on it. That was kind of like a good step back for us to do.
Yeah. And I know the feeling of thinking that you're close to done. You're right near the end of what you need to shoot, and you've got the camera on, and you've installed the Python scripts and the pip and all of that, and you run the script and you've got the camera on and you say, and voila, there we are. But actually, you get a whole bunch of red text that says device not found. It's another 4 hours of Googling, and these days chat GPT, thankfully.
Yeah, you get in like this little avalanche of like, I know this isn't the right way to do this, but we're so close. So we're just going to like just nudge it down. And then you get down to there and it still doesn't work. And you're like, okay, I know this isn't how I'm supposed to do this. And then you finally look back at it and you just made so many bad decisions in a row that it end up losing more time than you save.
Yeah, but you learn from them, and you do make bad decisions sometimes. What comes to mind for me is not really many years ago, not really understanding the permission system in Linux. So whenever you got an error, just make it chmod 777. That solves everything, even though it's not a good idea.
Yeah. A lot of the lessons that I've learned this year have been just with the limits of what you can remember and like why, like, you know, it's the unsexy documentation that really saves a lot of engineering projects. Not trusting yourself to remember something, even though if at the time it's going to feel like the most important thing ever. There's no way you could possibly forget it. Just write it down. Just write it down. Just document it. Just spend the time. Yeah. Exactly. Those lessons are also hard to show on content, like when you're trying to do content creation, because it's not sexy. Like people don't want to see a story about why keeping an engineering notebook for every project is a good thing. That's boring. They want to see something explode.
Yeah, exactly. Like Electro Boom.
Oh, amazing. So I got to meet him at Open Source, and I was just nerded out to him. I was like, wow, you're so good at communication, because he makes it so entertaining.
Yeah. I've got a good story about documentation. I know this isn't about me, but it's a funny story anyway. I had these 2 VCRs because I'm old school that way, and I have a lot of VHS tapes that I want to digitize. So they had this feature where they could both share one remote. All you had to do was punch a special key sequence into the remote, and then you control VCR1. And when you want to control VCR2, you punch a special key sequence. But I could never remember that sequence. And every time. So one time I had to Google it. I had to find PDFs from Russia and places where they've scanned manuals and dig through them. And eventually I found that damn key sequence again. And I said to myself, I don't want to forget this again. I want to write it on the back of the remote. So I went and found myself a Sharpie, turned the remote over, and instructions were already written there. I had done it before the last time.
Oh, man.
I want to speak documentation and Espresso shortly, but I'll just check in with the audience. And yes, it's that time to tell you about the code word. This is the prize we're giving away. It's the Elektor Raspberry Pi Pico Advanced Kit. It's a complete microcontroller learning package. It's designed for makers, engineers, hobbyists. It includes 2 Raspberry Pi Pico boards, a smart card kit, and a variety of sensors and modules, making it perfect for hands-on experimentation. As we were saying, Alex and I, having something actually move is far more impressive to a kit. With over 80 projects covering everything from basic electronics to advanced applications like RFID, motor control, sensor integration, it's a great way to explore embedded systems and develop real-world skills in microcontroller programming. So that's the web page, if I can give you the word. And the URL is quite long, elektormagazine.com/elektor-engineering-insights-giveaway. Sorry about that. And the code is Etch, in honor of our friend Alex here, who's joined us with his amazing Etch-a-Sketch project. Now, looking at the audience, Electronics hat, Every Flavor Robot, one of my latest favorite YouTube channels. Yep, so you have been discovered. Thanks, Orange Lego. And Fernando Gonzalez Sidas says, didn't know the channel, subscribe now. Well, there you go. Now you've got 50,001 subscribers. And then Chris Meyer wants to know if your projects are in your leisure time or as a profession, or I would ask, is it student projects?
I think it's a good question. Our channel started as it started just as a way of Swapnil and I kind of like taking a step away from our jobs and being like, okay, how can we just do we want to do art, we want to do science, we want to do just good for the sake of art, science, and good. We weren't trying to make money off of our YouTube stuff, and we were just kind of sharing things that we were building around the house. But we were taking kind of like a gap from our career, like our normal career. So the answer is kind of somewhere in between. We don't make enough money from YouTube for it to be our profession yet. And we're doing a lot of other engineering to keep the lights on, but we are trying to move for it to be a big piece of our thing, because it's a very to me, it's a very enticing model to be able to teach people and then have the people that are watching and learning generate the ad revenue that gets to teach them more. That seems very nice. It seems like a better way to do it than functionally otherwise economics get in the way of doing anything that's useful, we've all been there in the job force.
Yeah.
So yeah, I don't know if that answers that question.
Yeah, that is a sad part of modern life. It's what's interesting and what will make money. And then a lot of organizations tend to chase to the bottom of the barrel because that will get them views. I mean, I'm speaking old examples here, but MTV used to have music, but they found more money in reality TV. And just the History Channel was meant to be about history, and they became UFOs and that sort of thing. It's just follow the money. And you've got to tug that rope to try and keep yourself sane. Now you mentioned ESP, and just on your channel, which I discovered before it was so cool and popular, I was an early adopter of ESP8266, but you mentioned bad documentation. Now that was bad at the time. It came on an ESP01 board, I think, and the only documentation I could find at the time was basically AT commands to command it over a serial. So I would use it as an extra board on an Arduino to get Wi-Fi up and running. And half of the commands weren't completely written. They were just empty functions in their assembly programming because they hadn't gotten there yet. But I managed to get it going. Isn't it amazing how far Espressif has come since those days?
Wait, can you repeat that one?
I said, isn't it amazing how far Espressif has come since the early days of the 8266?
Yeah, and when I was working in industry, we would actually get to go back and forth with the Espressif team a little bit, and and they're really involved. It's a really cool thing to see the multiplication of efficiency happen whenever a dev package is actually supported, and then the engineers get to benefit from it, and Espressif gets to benefit from it because more people are using their stuff. Um, I definitely, that's one of the things that keeps me using Espressif chips, is because like I like how well documented it is.
Yeah, and I'm keen to get my hands on some of their RISC-V stuff, since that's all the rage lately. Although I do have a couple of Raspberry Pi Pico 2s, which have a couple of RISC-V cores on them.
Mm.
Now, if you're starting in robotics, what would you say a common mistake that people would make when trying robotics? I am useless mechanically, just so I can put that there. You've got mechanical engineering. You're light years ahead of me. I can do stuff with electronics, but to make stuff sturdy and, gear ratios and all that sort of thing, that's, I just don't get it. I wish I did.
Oh. So are you wondering like specifically in mechanical engineering? Like what do you think roadblocks are for people getting started in robotics?
Yeah, if
Or
you're
just in
starting to
general?
build something, what mistakes do you commonly see people making? Because you're in that field and people are learning all the time, and there must be some things that come up a lot that people do wrong, like putting an extra in software, like putting a semicolon at the end of a for statement.
I think in terms of mechanical design, there's definitely like a little, just like knowing the very basics of electrical design, like let you do so much more and avoid so many more mistakes, knowing Ohm's law. There's like the equivalent in mechanical design of like understanding how your materials work. So some materials people have a really good intuition for, of like, oh, like wood can split really easily in one direction, but it's more strong in the other directions. But I see a lot of 3D printing people just kind of designing these like magic pieces and then being like, well, why can't I make it? Why can't my 3D printer make it? I thought it could make anything.
Yeah.
But really, I mean, it's material science. It's basically a hot glue gun, depositing things. And if you understand that, like at those layers, it's really weak. And then I would say, like, besides the very fundamentals of like understanding your materials, it's not getting too overwhelmed by it and realizing that you don't have to design everything yourself. Like very rarely does a new idea have to be formed, because there've been engineers for so long that almost every problem that you're going to run into, especially if you're a beginner, and arguably if you're a beginner, you should only be like doing stuff that is already solved. Um,
Yeah.
Mechanisms already exist. So I think people should be like utilizing more from like just trying to replicate first. I think that's what I'm trying to say. People try to jump in and be Iron Man, and they're trying to like invent something like crazy, but you would learn a lot just from like trying to replicate what you see that works well. And it's not, people get the idea that it's going to feel like you're just copying, but even replicating stuff that you see is a lot of creative process is needed for it.
There's a lot of times when structural or mechanical engineering is not grasped intuitively, like in the movies. I saw a movie once where Superman grabbed a plane and carried it away by gripping it on the wings. Doesn't matter how strong you are, you're not going to carry a whole plane on two little points of contact. At least I know that much, but not much more than that. Let's have a look at a couple more questions here. From Orange Lego. Why is keeping an engineering notebook useful for projects? Is that more useful as a content creator, or can it be relevant for hobbyists as well?
I would say it's less relevant for a content creator than a hobbyist, because I have a ton of footage to document my process as I'm building it, and the design decisions that I'm making. I'm, usually talking to my camera about like, oh, this is why I did this. This is why I did that. When you're debugging stuff, it really helps to know what thought process and what exact steps you were doing in the past. And that's why I recommend keeping your notebook. It helps you remember these like day-to-day details, because I mean, if you're a maker or a hobbyist, like you probably have a lot of things going on at once. You're probably like doing this project for a couple of days and you get bored of it. And then you pick up this other one, and then you do that one for a couple of days and you get bored of it. So having a notebook lets you pick up and put down things without risk of, forgetting. And I can't tell you how many times like it seems so silly. Like there's no way I would forget that this is the power line and this is the ground,
Yeah.
or that this is the signal and this is the power. This is 3 volts. This isn't a 5-volt system. And then I come back to it because I didn't write it down and I just blow something up. Like,
Yeah, exactly. Even something as simple as screws. I find that maybe I'm lazy, but making notes slows me down a lot, and I just want to get to the end goal as quickly as possible. But yes, I will take something apart, and obviously I'm going to know that screw came from there and that one came from there, and then you come back to it the next day and like, got extra screws left. I don't know what happened there.
And in electrical design, I've had, like a very concrete example of messing something up like this. I once designed a power system for one of our microcontroller, like motor control boards. And I was like designing this board, and I was designing the power system to buck regulate something down. And because I had worked on it for like a whole week, I was like, I have all these numbers, like I'm not going to forget them. Come like months later, after we had already ordered the board and have it, something came up and a question was, what is the absolute max voltage rating of the buck regulation? Because we had been running it on 3-cell batteries, so we knew it was like rated for 12 to 15-ish volts. But we were like, what is the maximum? And in my head, I was like, for some reason, I just really remembered the number 17. I was like, 17, 100% certain, like we're good to go. And I didn't have the files anymore because it was a long time ago. I couldn't really go back and look at what capacitors we had chosen on the board. They weren't like, it wasn't written on the parts. And so we really were just guessing. And if I had just written it down, that would be that's like such a simple question, like that we should have the answer to. But no, that exploded. The capacitors like it was only rated to 15. We thought it was like 17. Stopped working.
Ouch. And we were speaking about teaching earlier, and just like writing documentation, teaching as well clears up the concepts a lot in your mind, because you have to, when you do the documentation, you have to be 100% certain. Whereas before you write it down, you've got a rough idea. But a rough idea is not good enough for documentation and for classes.
Yeah, totally.
Frank DeHart says he has a variety of ESP32 boards, 54 plus pieces. Why, Frank? Why? What are you doing with those? A couple of ESP8266, several Raspberry Pis, guilty. And he prefers the ESP32 though.
Yeah.
I wish I could say I've had as much ESP32 experience as I had on the Raspberry Pi. And here's a good question. We've been talking hardware the whole time. Jorgen Sandberg wants to know, please get into some detail on software frameworks for robotics and their capabilities.
So I will admit, Swapnil is much more adept at all of the software side of the robotics, just because every time we've had the chance to explore these things, Swapnil's been the guy to take it up. Oh, he's answering from bed. Look at that. He's in the comment section.
Oh, nice. There we go. Hey, Swapnil. Sorry you're not feeling well, but I'm glad you could at least join us a little bit. If your fingers can move without too much pain, feel free to answer some questions in the chat as well.
But to answer on Jorgen Sandberg's question, I think like one thing that Swapnil and I found recently, we've known about it for a long time, but we haven't had time to like actually go through and explore it and nearly as in depth, but has been pleasantly surprising, is the ROS2 stack. Like just the complete like beginning examples of ROS2 are such a great place to start. It used to be whenever we were in college that like getting started in ROS was kind of a lot more overwhelming than it is now. But I actually have like a 10-second video of something I could show y'all in VLC again, if I pull that up.
Yeah, sure. If you have to look at it for a moment, I can look at some questions. And also you mentioned the ROS2 stack. I just Googled it as you were talking. Zoom in a bit. Is this the right thing?
Yeah. Just the ROS2. They're like getting started.
Very interesting.
They have, just reading through their getting started guide, and all of these things. I think if you're looking at like, you're kind of comfortable with microcontrollers and motor controllers, and you want to start building a robot that can do something like slam, there's like some really cool things here in ROS 2. And actually I have an example of one that we built, and we're actually going to make a video coming up on our channel soon. So this is a Lego. This is an ESP32 microcontroller that we put on top of a Raspberry Pi. It's a Pi hat that we're building. And we slapped a LiDAR onto the USB. And this is like a Lego robot that we were able to build in like a single day, super fast. This is not a complicated robot. But with ROS 2, the same day, we're able to like map our house.
Gee.
And so you can see this is like a little foxglove video of it driving around in our house and moving and mapping. And so like this is something that like we would have spent months and months and months on in college, because the software support used to not be there. But now we can just kind of play around with it.
Yeah, it reminds me of what we were saying earlier about how Arduino just made it so much easier to jump in with microcontrollers because there was a software support system.
Yeah, it's amazing. That was all of my 10-second video. We could take that off the stage now.
Cool. Question here from Peter. I would like to try out a BLDC motor board. Would you create it? Where can I get it?
Right. So they're only in alpha like testing right now, but we have a couple on our website at motorgo.net.
Let me bring that up and have a look. That's the most interesting stuff.
Right. So there's a picture of the robot that I just showed you all driving around in our house. That was built on the MotorGo Plink. So that's a DC motor controller Pi hat. And then the MotorGo Axis is the one that we have inside of the Etch-a-Sketch. And that one is it has two BLDC drives inside the MotorGo Axis. And all of them are Pi hats that work as Pi hats, but they also work as standalone because the ESP32, so it's so standalone powerful that it doesn't even need the Pi to do most things. It has a 9-DOF IMU on it. It has a power stage capable of powering the Pi at 5 volts at 5 amps. And then it has its motor controls. So yeah.
Nice.
And that's all open source too. I don't know if it's the best business decision, but we share
into the chat. Motorgo.net. There it is in the chat. Carry on. Sorry, Alex.
I was just saying all of our designs are completely transparent. Have you ever heard, speaking of that, have you ever heard of the Key Canvas like PCB viewer?
No, I don't think I have. Because
I've seen a couple of KeyCAD videos on your channel before, or like the webinars. Recently, you should Google Key Canvas.
Okay, let me do that right now.
KICANVAS. This is a really cool software tool that people should know about, I think.
Wow. Paste a GitHub link. That easy, huh?
Yeah, so you should paste, or actually, I could send this link into the chat. Oh, it didn't really post as a link.
Let's have a look. Yeah, I can bring it up on screen, but to copy and paste it, that's another story.
This is just cool because you can put in like a GitHub link and look at like PCB files, like all of the layers, all of the schematics and stuff. And we use KeyCAD, so this is a cool tool I wanted to share with everybody.
Yeah, I wish I could try it out, but to get to that link without manually typing here and making everyone wait 5 minutes while I type out that long URL. But they do have a video demo here. So maybe that can give us some insight into what you're telling us. But I mean, for it to just ask you to dump a GitHub URL and just take it from there, that already looks impressive. There we go.
Very neat.
So keycanvas.org, it is in the chat at the moment. Okay, so we're reaching the end of our time. I want to ask you about your future. Are you working on any really exciting projects that you can tell us about?
Yeah, so I mean, I mentioned it a couple times, but we have we're building an educational like collaboration with Carnegie Mellon University to make like a whole course to teach people robotics, and it's based around our hardware that is going to be like, this is a Pi hat, sits on a Pi. We have it inside of a Lego compatible case, and we're able to like slap together robots that have lidars on them and do slam around the house and navigation. And this is kind of a dream project for us. We're really excited about it, to be able to actually have our hands in like the education of aspiring roboticists is really exciting to us. And hopefully we'll be able to move this board and this platform to universities across the country too. I know a lot of them look towards Carnegie Mellon for like their robotics education. So hopefully if we can, kind of prove this out with this class, that we can help more people.
Yeah, and you personally, what's your future looking like? Engineering, starting a startup, becoming a lecturer at a university?
Oh, well, this is what I'm doing here at Every Flavor Robotics. I think like people ask like if I was given $1 million or $1 billion, like I would be doing exactly what I'm doing now. Like I think teaching people, developing open source hardware. If people can let us do this and keep the lights on, then I'm going to do this as long as I can. I really want to make robotics as accessible as possible, and we're going to keep going with it.
Well, that's awesome. There's nothing like doing what you love and keeping the lights on at the same time.
Right.
Having a look at what you showed me there, ROS2, Swap dropped in and said the beginner guides for ROS2 and NAV2 are a great way to get autonomous mobile robots fast. Looks like he's excited about our conversation. He might get better sooner. We broke him out of that little virus, the sniffles. We've all had them this month. Anyway, Alex, I want to thank you so much for joining us and taking the time this hour out of your day. It's relatively early there on the East Coast where you are. And before I let you go, I just want to let our audience know, because we have been talking about Espressif. Tomorrow we have a webinar from Anand Gupta from Espressif, and he'll be talking about the ESP32 P4, which is a whole different breed of chip from Espressif. So yeah, you could find us here, same place, same time, different day, tomorrow the 30th of January, and get to know about this new chip of theirs.
Oh, that's really exciting.
Yeah, if you're around at 10 a.m. Eastern, I believe it is, same time as today, then yeah, drop in and say hi.
Thank you so much for having me. This was a lot of fun.
Cool. Thanks, Alex. It was great of you to join us. And to Swapnil, in fact, I'm going to give Swap a little bit of due here and drop in the Discord link, as he's asking us to do on screen. It's in the chat now, discord.com/invite/ well, the rest of it is there. Yeah, they do have quite an active Discord, and that's where I found that it took months to edit a 28-minute video. Can't do that in breaking news. Anyway, Alex, thanks very much once again for joining us. And thanks to our audience from around the world, the regulars and the new guys, and to our new members on the YouTube channel. And for those of us entering the competition, for those of you, I'm not eligible. Good luck. And if you want to know how to enter the competition, just rewind the video. It'll be out on YouTube. Thank you very much, audience. And thank you very much, Alex. And goodbye.
Goodbye.